In the last lecture, we saw the analysis of practical transformer with no winding resistance and no leakage reactance. Let's extend our understanding by analyzing the phasor diagram for an RL load. This will help us comprehend the mathematical approach more effectively. Here we see the phasor diagram representing the current components and the voltage relation for a practical transformer under an RL load condition. First, let's recall the no load current I naught. It consists of two components, in phase or real component IC, which is responsible for core losses, the reactive or magnetizing component IM, which establishes the flux in the core. The power factor of the no load current I naught is given by cos phi naught, and the phase angle of the no load current is phi naught. Along the positive y-axis, the real or in-phase component IC or I naught R is equal to I naught cos phi naught, and along the positive x-axis, the reactive or magnetizing component of the no load current I naught, which is IM or I naught x is equal to I naught sin phi naught. Next, we have the secondary current I2 and the load component of the primary current or the secondary current referred to primary or I2 prime. This is another component of the total primary current I1. This has the power factor of cos phi 2 and the phase angle of phi 2. The real component of the secondary current referred to primary or I2 prime R is equal to I2 prime cos phi 2, and the reactive component of the secondary current referred to primary or I2 prime X is equal to I2 sin phi 2. So the total primary current I1 has both real and reactive component. The total real component of the primary current I1 or I1R is equal to real component of the no load current and real component of the secondary current referred to primary. So total real component of the primary current is equal to I naught R plus I2 prime R, and also the total reactive component of primary current or I1X is equal to reactive component from the no load current or I naught X, and the reactive component from the secondary current referred to primary or I2 prime X. The total primary current I1 is the vector sum of the reactive real component and the reactive component. Hence, the magnitude of the total primary current I1 is root over real component of the primary current plus reactive component of the primary current. Let's take a look at our first mathematical problem. A 440 by 110 volt single phase transformer draws a no load current of 5 ampere at 0.2 power factor lagging. If the current of 120 ampere at 0.8 power factor lagging is supplied by the secondary, then we need to calculate the primary current and the power factor of the primary current. Here the given quantities are primary voltage V1, which is equal to 440 volt, secondary voltage V2 or 110 volt, no load current I naught is equal to 5 ampere, and the power factor of the no load current or cos phi naught is 0.2 lagging, and the secondary current I2 is 120 ampere. The secondary power factor or cos phi 2 is 0.8 lagging. At first, you will calculate the turns ratio K, which is the ratio of the number of turns in primary by number of turns in secondary, which is also equal to the supply voltage in the primary winding by the load voltage in the secondary winding, or V1 by V2, which is equal to 440 by 110 or 4. With the value of this turn ratio, we can calculate the secondary current referred to primary or I2 prime, as I2 prime is equal to I2 by K2 or 120 ampere by 4, which will give us 30 ampere. So the secondary current referred to primary or I2 prime is 30 ampere. Now let us do the calculation for no load current. At first, we will calculate the phase angle from the power factor of 0.2, and the phase angle will be 78.46 degree. So the real component or I naught R is equal to I naught cos phi naught, which is equal to 1 ampere, and the reactive component or I naught X is equal to I naught sin phi naught, which is equal to 5 into root over 1 minus the value of cos phi naught, which is 0.2, which will give us 4.899 ampere. Next, you will calculate the components for secondary current referred to primary or I2 prime. At first, the power factor is 0.8, from where we can find the phase angle phi 2 as 36.86 degree. The real component of the secondary current referred to primary or I2 prime R is equal to I2 prime into cos phi 2, which will give us 24 ampere, and the reactive component or I2 prime X is equal to I2 prime sin phi naught, which will give us 18 ampere. Using the real component of no load current and the secondary current, and also the reactive component of no load current and the secondary current referred to primary, we can calculate the real component and the reactive component of the total primary current. Hence, the real component of the total primary current I1R is equal to I naught R plus I2R, or 1 plus 24, which will give us 25 ampere, and the total reactive component of the primary current or I1 X is equal to I naught X plus I2 prime X, which will give us 22.899 ampere. So the magnitude of the total primary current or I1 is equal to root over I1 R whole square plus I2 R square, which will give us 33.9 ampere. And finally, the primary power factor cos phi 1 is equal to the real component of the primary current or I1 R divided by the magnitude of the primary current or I1, which will give us 0.737 lagging. So finally the primary current I1 is equal to 33.9 ampere and the primary power factor phi1 is equal to 0.737 lagging. Let's take another mathematical problem. In this problem, we have a single phase transformer with a trans ratio of 6000 by 400 volts primary to secondary voltage, and it takes a no load current of 0.7 ampere at 0.24 power factor lagging. If a current of 120 ampere at a power factor of 0.8 lagging is supplied by secondary, then we need to estimate the current drawn by the primary winding. So before solving, let us list out the given quantities. Here we have the primary voltage V1 as 6600 volt, secondary voltage V2 as 400 volt, no load current I0 as 0.7 ampere, and the power factor for no load current is 0.24 lagging, and secondary current I2 is 120 ampere, and the power factor 0.8 lagging. Next, at first, like the previous math, we'll calculate the turns ratio by taking the ratio of the number of turns, which is the ratio of the supply voltage or V1 by V2, which will give us 16.5. Next, you will calculate the secondary current referred to primary or I2 prime by dividing the secondary current by the turns ratio, which will give us 120 divided by 16.5 or 7.27 ampere. Again, we will calculate the components of no load current. At first, we will calculate the phase angle phi naught, which will be 76.105 degree, and then we can calculate the real component as I naught cos phi naught, which will give us 0.168 ampere, and the reactive component of the no load current as I naught sin phi naught. And like previous, we can calculate this sin phi naught from the value of cos phi naught by applying the formula. Sin phi naught is equal to root over 1 minus cos square phi naught. From there, we can calculate the reactive component as 0.6796 ampere. Next, we will calculate the components for the secondary current. From the power factor of 0.8, we can calculate the phase angle as 36.87 ampere, and the real component of the secondary current referred to primary or I2 prime as I2 prime cos phi naught, which will give us 5.8182 ampere, and the reactive component I2 prime x as 4.36 ampere. Next, we will calculate the components for the primary current I1. At first, we will calculate the real component of the primary current I1 as I1R, which is the summation of the real component of no load current and the real component of secondary current referred to primary or I2 prime, which will be 5.9862 ampere. Next, we will calculate the reactive component of the primary current I1X, which is the summation of the reactive component of the no load current and the reactive component of the secondary current referred to primary or I2 prime, and it will be 5.0432 ampere. Again, we can calculate the magnitude of the primary current I1 as the vector sum of the real component of the primary current I1R and the reactive component of the primary current I1X, and the magnitude of this vector sum will be root over I1R square plus I1X square, which will give us 7.827 ampere. I have 3 homeworks problem for you. Give them a try and post your answer in the comments. That's all for today's lecture. If you have any question, feel free to drop them in the comments and I'll be happy to help. And also don't forget to like this video, subscribe to my channel for more updates. It really helps and means a lot to me. See you in the next one.